Hello, everybody, and welcome to our Google Hangout where we're talking about are the days of secure email over? My name is David Strom, and I've been writing about this subject probably longer than most folks, and the recent set of stories about the death of secure email are somewhat frustrating. I'm going to show you a couple of screenshots here of what different websites. You can go out and check them out if you'd like. This first one is the one from IT World, and you can see that where the columnist there is talking about secure email being dead and don't believe all the hype. In the article, he talks about email, as wonderful as it is, can't and shouldn't be trusted, even if it's encrypted 6 ways to Sunday and stored in a cloud-hosted server on the island of Togo. Simply put, the days of secure email are over. That, of course, assumes that particular point of view, that there actually was a time when secure email was popular, which probably hasn't yet happened. So we're going to talk a little bit today about what's going on. Certainly the news over the past month hasn't been very encouraging. Two secure email providers, Silent Circle and LavaBit, have shuttered their servers rather than take any chances that their customers' data would end up in the bowels of the NSA's Utah data center. Here's an article on ZDNet, which talks about why they turned off their email service. And then the service Grok Law, which is long a labor of love for some journalists and lawyer types, is also shutting down rather than give out their information. But one person's gloom is another person's opportunity. Here's a project called Mailpile, which is not yet available, but they've reached their Indiegogo fundraising goal very quickly with all the various news and gloom and doom about what was going on with the NSA. They're now off and coding, and they promise to have their service up and running early next year. We'll see if that actually happens once everything dies down. So is it time for enterprises to get more serious about encrypting their email by default? Should they just give up? And that's what we're going to talk about today. Let me just give you a little bit of my background and then introduce our two experts as well. I'm manager of the DICE security talent community, which you can find over here at news.dice.com. And I put all sorts of information on here, including latest news articles, security events, and security folks on Twitter, and organizations and certification information. So it's a nice resource. I also write for other IT B2B websites and pubs, including Network World and GigaOM Pro. And in 1998, I was the co-author of a book on enterprise email with Marshall Rose, who was one of the original authors of the Internet Email Protocols. So I continue to write about security and enterprise IT topics. Joining me on the second screen is Doug McLean, who is the Senior Director of Product Marketing for McAfee Labs. And Doug has been around the secure email space for many, many years as well. He was formerly an executive with the PGP Corporation. The PGP was one of the original encrypted email providers and is still very active in this space. And the last screen is Stephen Sprague, who is Wave Systems CEO. And Wave makes a number of security products, including this browser plugin called Scrambles, which lets users control who sees the content they post to the web and help encrypt the data. What I find very interesting, we'll start things off, is this article that I came up with in the New York Times Magazine from 30 years ago, 1983, which talks about a book that David Burnham had written, and all the various things that the NSA is accused of and we're horrified about pretty much are revealed in this book from 30 years ago. So I thought that would be a good way to start the conversation off. And gentlemen, if you want to talk a little bit about why all the hubbub right now, why these folks that are exiting stage left because of fear of having their customer data uncovered.
So I think the motivation of the ISPs that are dropping out of the space is pretty clear. If you run a mail service, you inevitably end up collecting a lot of metadata, even if all of the content is encrypted, in terms of the headers and the ISP source and who you're communicating with, etc. and they concluded that hanging on to that data just made them potential targets of governments globally. It wasn't just the American government. Taken from a strictly commercial standpoint, I think their decisions were pretty sensible. But it begs the question that you teed up initially, which was, okay, if that's the case, does that mean that we all need to take encryption of our communications into our own hands?
I would sort of add to that I think you have to take encryption of your communications into your own hands, because at the end of the day, it's control of the encryption that actually facilitates the communications, and the transport layer and the infrastructure to deliver should ultimately become irrelevant. You should feel comfortable to put it on any system. One of the ways I like to think of this, and it's sort of an out-of-the-box thought for everybody, is some of the most secure message delivery we have is the delivery of the nuclear launch codes. And we do that over the public network called airspace. Right? So everybody's comfortable in understanding that we can deliver a nuclear launch code to a submarine, and we do not have a fiber optic cable hooked to the back of the submarine in the middle of the Atlantic Ocean, all the way back to wherever who's going to type the code in. So by default, it was delivered over a publicly available network, and everybody's got an antenna in Washington listening. And so it's a very interesting context of what does it mean to have secure messaging over public networks, and it's about who does own the encryption and the keys, and I think the keys are a very interesting piece of the puzzle.
Well, we hope. Go ahead, Doug.
I think you put your finger on the core issue. When it comes to individual control of secure communications, where the user actually has control of the keys, it's a great system. Where it gets really complicated is when you're trying to do secure communications for either a government agency or a private enterprise. The key management problem just becomes overwhelming very, very quickly. And to my knowledge, no one has really solved that problem yet. The core encryption algorithms are commodities at this point. Anybody can buy an RSA license. But how exactly you do the key management such that both the end users and the enterprise in question have appropriate access is a very, very hard technical problem to solve.
So Doug, we had an interesting experiment, and you mentioned previously you mentioned the Scramble site that we put out, and we learned an interesting thing, which is that one of the greatest problems with email encryption, and email encryption has been sort of the holy grail, it's where everybody starts because we think it's the largest traffic communication, is interesting in that email has a fundamental problem, which is you perform transactions to people you don't know. And so the problem with a keying infrastructure is when I have to send an encrypted message to somebody I've never done business with before, then I have a fundamental problem, which is how do I get them the key? Right? I send them their email was printed on their business card. Their 256-bit key was not printed on their business card.
The first use problem is always hard too.
Exactly. What's interesting is in social networks, that's not actually true. Almost everybody in a social network performs a friending process at the beginning of the process. And so that first introduction is an opportunity to key. And so in some ways I would argue that today the easier problem to go after attacking would be social encrypted communications. And from that, we might end up with a foundation to go do the communications with people we've never met before.
Oh, it's far easier because, again, it's a peer-to-peer key exchange problem, right? And we've had solutions in place for that for a long time. PGP, we called it the network of trust, where we would do actually key exchange parties, and they were social events. Unfortunately, that process doesn't scale into the enterprise.
I would just argue that Twitter might argue with you on that subject. The people following somebody's Twitter feed is an opportunity to get keyed. I like Twitter a lot from a crypto perspective because the other thing that is an enormous problem with secured communications is classification of data. And hashtag Madonna is just phenomenally in use today, and we've trained all the teenagers how to use a hashtag, but don't ask them to go to work and classify data because they won't do that.
Right.
You know, it's an interesting thing. Is like we should stop talking about data classification and start adding hashtags to Word document. You know, hashtag classified or hashtag eyes only. Yeah, the teenagers would totally get that. But you talk about data classifications and classification levels, and you can have training opportunities all day long, and they have no idea what you're talking about. But you ask them to use a hashtag, they're good with that.
Yep.
So don't you think, though, that encrypted email is still too hard to use, which is why no one uses it?
So encrypted email is trivial to use. The current product implementations are really transparent to the end user. That's not the issue. The issue, in my parochial view, is the key management problem, which doesn't manifest itself to end users. It just manifests itself massively to CIOs and CISOs who, for regulatory and legal and privacy reasons, need to have multiple people having access to keys. And that's a hard problem that I haven't seen solved yet.
Well, PGP has their product. Voltage has their, I forget what they call their product. They're all, you know, web enrollment, relatively easy to sign up and manage your key infrastructure from there. You don't think those really work?
So, honest to God, I haven't looked at those products in a year or two, but the last time I did look at them, they worked, they were functional, but were non-trivial to administer in a reliable and regulatory compliant way. And so here's part of the issue, is you not only need to be able to create keys for users, you also have to expire them at appropriate times, and you need to be able to prove to your various regulators, particularly if you're a financial services firm, that you are doing that in an accurate and timely manner. And that's hard to do. And I haven't seen a product that does that yet.
So I think there's a huge change coming. And so there's this little project that's been going on in the world out there in IT called mobility. And mobility is an interesting thing because most people can't define what mobile is. And it's something that
like pornography. I can't define it, but I know it when I see it.
Exactly. Right? And so but I have a definition for it. I actually can give you a definition for what I think mobility is, which is a transformation from a network based on connections to a network based on the identity of the device. And so we're moving from a world where I plug my laptop into this copper connection, and therefore I am, you know, on this LAN or this infrastructure, to a world where my device has an identity, preferably a tamper-resistant hardware-based identity in the box. What comes out of that is if you realize we're moving the whole infrastructure to an identity-centric network, then link-level security doesn't work very well.
Absolutely not.
And so one of the things that's become intriguing, and I think came out of our exploration of our Scrambles project, which is really a message-level encryption. So every single message is uniquely encrypted. And there's a central independent key server. We never see the messages. They get encrypted locally. The message goes to Twitter or Facebook, or could be an attachment in an email. There's an independent key server that handles the policy. And that independent key server could be in France or Germany or UK or inside General Motors, or, you know, it could be in a variety of locations. In theory, you could actually have more than one, which would even be, in addition, interesting. And every individual message is encrypted. So now access to Dropbox is irrelevant because all the content at Dropbox is protected. And I do agree with the comment about the metadata. I think that is one of the greater challenges of beginning to reduce the amount of information we need for voyeurism. Just naturally, I think it's something that we have to all collectively work towards. But the context that there really is no operational reason why Twitter couldn't be 100% protected messages. And when you do that and every message is uniquely encrypted, then instead of revoking a specific key, which is in reality technically what you're doing, you're actually beginning to learn about revoking messages. And so when we think about this, we think about things like, what would happen if you'd like to expire the first 14 years of your Facebook profile, not by deleting it or asking for the right to be forgotten, but by changing the group that it can be shared with. So I could revert, for example, everything from the time I was born till the time I go to college to be only read by my mother and I, and now I can start a new life in college, but I didn't want to delete those social histories. I wanted to have them available to me so that when I get older, things you did when you were 14 are funny when you're 45. They're not very funny when you're 17. And so it's an interesting context of a message level encryption for this message level infrastructure that we're in. And I think it's, anyway, it's been a very interesting experiment so far to play with. And it changes the picture from an email-centric model where you and I share a key and now we can communicate. Really what we need to do is both belong to a service that will facilitate the communications.
Yeah, what you're talking about was, David and I were having a brief conversation before we got started about a company that did exactly that back during Internet Bubble #1 called Disappearing Ink, where a unique key was applied to every message, and rather than throw the message away, they just threw the key away so no one could read it anymore. It may be they were just too early for their time.
Oh, yeah.
What's interesting now is the concept of, so of course if you did this, you know, Google made the statement during the midst of this that we shouldn't encrypt all the messages because that would reduce the value of the service, which I thought was great fun. But imagine, because they can't search everything, right?
Right.
Right.
So the interesting thing is, well, what if you could friend the service? So in other words, I produce content, all of it's encrypted. I retain ownership. I share the right to use my content for some period of time, but that right expires. And the fact that that right expires is in and of itself a very interesting model for the internet. And we're finally at a point where processing power-wise, those additional transactions to decrypt a piece of information prior to searching it or categorizing it or looking at it, etc., is not impractical right now. It actually could be done in very large scale. I mean, we're doing it in Facebook for what everybody looking at every Facebook page only has a cost of, you know, $4 or $5 a year. That's their total operational cost for all of Facebook per user. So it is very practical to execute.
Interesting.
Interesting. How many people are using your Scrambles service, Stephen?
It's still only measured in the thousands. I think it's one of the interesting challenges. I think the things we've learned are lots of people talk about privacy. Not very many people are actually interested in executing privacy. I think the thing we've learned...
Well, Facebook is certainly a case to prove that point. I don't know anybody who can look at their Facebook privacy settings and figure out what the hell is going on there. It's just a mystery.
I think it needs to be built in. I think that's the conclusion we've come to. We've spent a lot of work building a developer toolkit for Scramble so people can play with it. You can go build an application of your own that does whatever you want. The key server is completely handled for you. So you want to go build an application on top of Twitter or Independent or secure texting, you can just go use the public APIs there and leverage them. And so the message level encryption is just sort of magically taken care of. And the key server problem is a real problem. I think that our view today, and it has been for a while, is that there's a network of key servers, not a single one. And that you most likely want to belong to a key server that's in a sovereign control that you're comfortable with the legal requirements of that area. We're not trying to support a terrorist communications model. It's important to have a legal construct that works.
Well, you know, that's a very interesting point. I was going to bring that up. I don't know about if your customers are talking about this, but a lot of my readers are asking me, where can I host my email outside of the United States and the UK where I have a modicum of protection, or where I think I'm going to have a modicum of protection and not be snooped on?
So my view is that my click-through agreement for this is the U.S. Constitution, and I signed up to that click-through agreement when I got my birth certificate. Right? A French citizen doesn't sign off on that click-through agreement, right? So it is perfectly legitimate for the U.S. government today to spy on all foreign communications. They have no protections. On the other hand, we as citizens have protections. The executive branch, the Congress, the legal branch, etc. They might overstep their bounds, but we do have a mechanism to address it.
So, David, or either one of you, there's a new book that just got published about a month ago called The Internet Police. How the criminals went online and law enforcement followed them, I believe is the subtitle. And I'm only about a third of the way through it, but the author recounts with great detail the experiment of Sealand. Do you remember this?
Oh yeah, Sealand. Yeah, whatever happened with them?
There wasn't a commercial proposition there, and as it turns out, part of the issue was that the rules of engagement for email, at least in the developed world, are so similar as you move from region to region that the answer to the question you just asked is almost no place is safe.
Right.
You really need to step outside the developed world and go elsewhere. But the problem with doing that is that the system of laws that Stephen referred to a minute ago don't tend to exist. So yes, you might be a little more private, but if you need to defend yourself, it's a real issue. Anyway, I highly recommend the book. It's very nicely written from what I've seen.
So for our listeners, we should talk about what Sealand is. It was this pseudo country off the coast of the UK. It really wasn't a separate country. It was a former World War II bunker of some kind. I think it was in international waters.
That is correct.
And they were trying to turn it into a data haven and put some generators and some servers in this concrete bunker of sorts.
Right. And it was originally in international waters, and then the UK extended their claim
right.
another few miles, and suddenly they found themselves under UK jurisdiction, and it sort of killed it off.
Right.
I think we need some basic protection. I think that as we speak now in security world, the new mantra is continuous monitoring, right? And,
yep.
And continuous monitoring is a sort of interesting concept when you apply it on the broader scale of this whole NSA PRISM conversation, right? They're doing an excellent job of a continuous monitoring infrastructure. So fantastic. They're like right out in front of the bleeding edge. I'm not sure that voyeurism is the best model. I think it is still important to go out and buy yourself, appropriate armor for the thickness, for the size of bullets that are going to be fired at you. A little tiny bit of encryption makes it so much more expensive computationally to watch. We were laughing the other day. I mean, if you really want to protect something, put 3 or 4 scramble servers around the world. Let's say one in Moscow, one in Washington, and one in Belgium, and then just triple encrypt the file. And so
all three.
They can be under the sovereign jurisdiction. We could give one to be run by Putin, one to be run by Obama, and one to be run by the EU. You can get the keys, but the paperwork will kill you, right? I think that there's an aspect of that where the actual cost of encryption is relatively low. If we can separate the content from the keys and provide controls for the keys that are in different jurisdictions, I think it really changes the service. And so the trick is you just don't want to buy keys from Microsoft and then use Microsoft's cloud services, and the same would apply to Google. You want to have keys from Microsoft and content stored at Google. You absolutely want multiple independent supply chains for access so that I force discovery to require at least more than one phone call.
I think that's very insightful, and I also completely agree with the comment you made earlier, Stephen, about it needs to be a network of key servers. Mm-hmm. And I actually saw the perfect physical analogy to this just last night. I coach my daughter's soccer team. Mm-hmm. And on the practice fields, we have to lock up the goals every night. Evidently, there's an aftermarket in goals where I live. And so we do it with one chain and 3 padlocks. And the padlocks each have a different combination, but you only need one of them to unlock the goals.
Oh, that's interesting.
So it's a little bit of a reach as an analogy, but
I like it.
I think it works. I think so. I don't know. I think I recommend the entertainment of scrambles. It's something to go play with. It's a free service. It's unclear yet exactly how. Not technologically it scales. The technology piece is really easy, but how this piece of the internet is missing. That the concept that the information that I create, that I publish into the internet, that I continue to have control over that for the life of that information is in and of itself interesting. And so it's a set of tools to go experiment with and explore. I think that we need more people exploring new paradigms of protected and private communications that are different approaches than we've seen in the past. For us, it's been an experiment. We haven't spent an enormous amount of money on it. We've learned a ton. And I think we understand how it fits into the future of the device really providing the service for you. If this would all work perfectly, your device would be a really excellent robot, and you would log into your device, and your device would handle access to all the information that's appropriate for you and that is capable of being received or created by the device that you're using, because not all devices are created equal.
Well, we're running out of time here. I just want to point out something that's on my screen. If you'll see here, we've got an article from the Register from last week, which talks about there's so many delicious ironies with the Snowden case. Here's somebody who we were talking about earlier about going to a jurisdiction where the rules of law didn't apply, and here's this guy stuck in Moscow, kind of ironically, thinking that he was safer there. But anyway, the Register has a couple of thoughts using some of the NSA's best practices for how to encrypt your communications and use asymmetric keys, and there's a whole series of prescriptions here using a higher bit encryption standard to make it a little bit more difficult to crack and so forth. So I would urge you to take a look at that.
Can I add one that's very important?
Sure.
Today, the general understanding is that if you want to take commercial off-the-shelf systems and get to a higher level of assurance, like classified or top secret, you can do it by having two independent infrastructures. So what you want to do is use a service from A and a service from B and double encrypt, because it forces compromise of both systems. Right. So that way, if somebody's cut a deal, or you've got a friend who's in the customer service department and can get you the keys or whatever, you now have to have two friends in two different customer service departments, and it turns out to be a multiplied problem of the risk. So if there's a 1% breach factor in each system, you multiply those 1%. It's a 0.01% breach if you combine them.
Doug, any last words?
I think I'm done for the day. Thank you for inviting me.
All right. Well, we're listening to Doug McLean, the Senior Director of Product Marketing for McAfee Labs, and Stephen Sprague, the Wave Systems CEO. My name is David Strom, here for Dice's Google Hangout on Secure Email. Thank you all for listening.